Hi, everyone. Welcome to this Q&A session with EMA Design Automation. Today, I'm chatting with Kenneth Wyatt, Principal Consultant of Wyatt Technical Services, LLC. He's worked in the field of EMC engineering for over 30 years with a specialty in EMI troubleshooting and pre-compliance testing. Kenneth will be discussing how to design your PCB with low EMI on July 22nd. He'll be explaining the physics of digital signal propagation as electromagnetic waves and how this will help dictate proper stack-up and circuit routing design for the lowest EMI issues. Thank you for joining us today, Kenneth. So let's get started.
Glad to.
So tell us a little bit about yourself and your experience in engineering.
Well, I got interested in electronics at a very early age. My dad was an electronic engineer, and it must have rubbed off. So I started taking engineering courses in college and seemed to excel at that. So my career really began in the aerospace world for the first 10 years, and then the remaining career was spent with Hewlett-Packard and Agilent Technologies as their EMC engineer. And then I decided to retire early from Agilent, and this was before they became Keysight, and went out on my own to consult in EMC.
Great. So you're going to be speaking in this upcoming webinar about how to design your PCB with low EMI. Can you explain why that topic is important to discuss?
The last several years I've been consulting. It's been predominantly for clients that are entering the wireless and cellular area and trying to add wireless and cellular to their products, or designing products that include those technologies. And it turns out that the circuit board design is really important to prevent onboard EMI sources from contaminating the receivers, especially in the cellular module. And so I started doing a lot more study on PC boards, because it's so easy to couple noise from, say, DC to DC converters right into the receivers on these modules. And when that happens, it generally decreases the receiver sensitivity to the point where the cellular providers won't allow that product on their system. So that's really where it all started.
Gotcha. So how does this webinar differ from webinars on the same topic?
Well, I'm going to pass on what I've learned through recent years of study and participating in other more expert PC board designers seminars. And really, the whole point of this is to pass on what happens in as far as the physics of signal propagation in circuit boards. And so that's really the main takeaway.
Okay, great. And why does this type of work interest you, and how did you get started in this topic?
Well, interesting question. So again, I think it all started with all my work in the wireless field or aspect of EMC, where really it's all these various onboard sources of energy coupling into wireless circuits and like GPS receivers and so forth. And so that really developed an interest in learning more about PC board design, because really it's all about the design of the PC board and the stack up that is chosen as to how risky you're willing to take with your design, because today's especially mixed signal and designs with wireless, you really can't use PC board designs that were common 10 or 20 years ago. And that's what a lot of designers are doing today, is leveraging what has been used before. And for really complex circuit designs, that doesn't work anymore for low EMI.
Okay, gotcha. So what are some common challenges in your experience that engineers should be aware of?
Well, so one of the main points I'm going to bring out during the webinar is the fact that there's really three things you need to understand as a designer. The first and most important point, and I think everybody understands, is that currents flow in loops, or signal currents flow in loops, and so that current wants to return back to the source. I think we all understand that. The second point is these loops need to be minimized in area, and I think most engineers understand that point, where we don't want to create loop antennas which will broadcast out various emissions, as well as be these loops can act as receiving antennas for external energy such as electrostatic discharge or radiated susceptibility problems. So that's the second point, is we want to minimize those loop areas. And I think most engineers understand that. The third point is what I'm really going to be teaching in this webinar, and that is that digital signals, at least above 100 kilohertz clock rate, propagate as electromagnetic waves. And most engineers aren't really clued into that. And understanding that point is really important when it comes to complex designs. And so we'll be addressing that. That's going to be a major point of the webinar. So
Great.
you want to definitely tune in.
Yeah, definitely. Is there anything else that you can give a preview of what you'll be covering?
Well, we'll be talking about routing of signals, stack up, and how important the stack up is. So those are two main topics. If you get the stack up wrong, you're off on the wrong foot already. And so it's really stack up is just a key design feature. If you get it wrong, you're really increasing your risk of EMC issues.
Gotcha. So does this apply only to complex designs, or can principles be like to simple boards as well?
Well, for simple low clock rate boards, it's not as important. Okay. And you know, a lot of designers get away with designs that aren't optimal and still can meet EMC. Mm-hmm. But yeah, as circuits get more complex, especially if you add wireless or things like motor control, people are finding out about these subtle issues in the automotive industry.
Oh, okay.
Where you know, you have large currents and larger loop areas, mm-hmm. And so you know, the more complex the design, the more important it is to get some of the basics done correctly right at the start.
Gotcha. So what can attendees expect to walk away with after attending your webinar?
Another good question. I think if they can understand point 3 of those 3 important points, being the fact that digital signals generally are electromagnetic waves that propagate within the dielectric space between the copper trace and the return plane. That is the most important thing and most important takeaway.
Okay.
Because that, if they understand the physics of what's going on and the fact that the copper traces are really waveguides, that should make it obvious how to design their boards for low EMI and best EMC performance.
Great. So what is something that you think attendees will be surprised to learn about?
Well, I think that point, the fact that digital signals are really propagate as electromagnetic waves. I was teaching this concept in front of an IEEE EMC chapter, a local one in Denver, and after the presentation, I had one elderly engineer come up to me and he said, "Ken, I had no idea about this concept," and so he seemed very appreciative.
Yeah. So is there any reason why not many people know about that?
Well, I've taken fields and waves classes, a couple of them, and I've read fields and waves books, and they don't explain it on a practical level. There's a couple exceptions. Dr. Eric Bogatin's books explain it. There's another author that I'll have in my references during the presentation that explains it. But there's a lot of interesting physics that you just don't learn in college, at least on a practical level. So that's an issue. In fact, the lack of EMC education is an issue I've editorialized on more than once. So.
Interesting. So who would you say is an ideal attendee for this webinar?
Well, certainly anyone designing PC boards, but nowadays an engineer or designer wears a number of hats. So they might do the design plus the circuit board layout plus any system design, and so really any design engineer that's either a system engineer or certainly a PC board engineer or otherwise a designer of electronic products, I think would benefit from listening to this webinar.
Great. What is some advice you would give to anyone that will be attending your webinar?
Well, come with an open mind.
Yeah.
Because what I'm going to teach is not well understood among the engineering design community. And if you can understand this one point of physics, you're going to have a competitive advantage over all your other competitors. So,
okay. And I know you've written a few books yourself, so can you talk a little bit about your books and the inspiration behind them?
Sure. So the inspiration, it's the books are all about EMC troubleshooting, and the first one here. Let me see if I can get it in the. There we go. Create your own EMC troubleshooting kit, and it goes into lists of equipment and probes and accessories that would be useful for doing your own in-house troubleshooting. And again, this EMC is rarely taught in colleges or universities, and so a lot of designers will go back and forth between the compliance test lab and their workbench and try and shotgun some things like adding ferrite chokes and rerouting cables and so forth, and going back to the test facility and failing again, and going back and forth, and just wasting time and money. And so in my own consulting, a lot of times I see the same old problems as far as designs, not necessarily PC board kind of designs, but in fact, the co-author on my original book on EMC troubleshooting, it's EMI troubleshooting cookbook for product designers, was co-authored by myself and Patrick Andre. And we got to talking during one IEEE conference and kind of lamenting the fact that we keep seeing the same old problems all the time. And so we decided to write that book, and it's been pretty successful over the years. And so this more recent series of books I'm writing, it's a 3-volume trilogy.
Oh.
And I've finished volume 1 and volume 2. Volume 1 was the one I just showed you on collecting the equipment necessary to do your own troubleshooting. Volume 2 is all about troubleshooting emissions.
Okay.
And that's they're both available on Amazon now. Volume 3 will be all about troubleshooting immunity or susceptibility problems, so like electrostatic discharge and so forth. So the real reason, and all these books are based on a compilation of blogs that I've written over the last 8 years for EDN and Interference Technology magazine. And so they both gave me permission to reprint and reorganize the blogs that I've written. And my specialty is EMC troubleshooting and pre-compliance testing and methods that you can use in-house to do that. And so that's really the impetus for writing this series of books.
Great. So other than your books and blog posts, where else can attendees go for further support?
Well, I have some information on my website, www.emc-seminars.com.
Okay. Great. Awesome.
And we'll have more references at the end of the presentation as well.
Great. We're looking forward to it.
Looking forward to joining you on the 22nd.
Yeah. So thank you so much for chatting with me today, Kenneth. Be sure to like and share this session, everyone. We hope you will join us on July 22nd for the webinar on how to design your PCB with low EMI. Thank you, Kenneth.
You're welcome. Thanks for having me.